idea of physical properties of acids, bases and salts. Now we are just moving to the chemical properties of acids. First of all, we are going to discuss about the acids, chemical properties of acids. First one, react with metals to form salt of metals and hydrogen gas. So what are the metals? Metals means just like lithium, sodium, potassium, magnesium, calcium, we are just those elements we consider it as a metal. So look at here, zinc. Zinc is also metal. Zinc combine with what? Hydrochloric acids. Zinc is a solid, hydrochloric acid is a aqueous. And it's what happened here? They are just giving zinc chloride. Zinc chloride is a aqueous and they are just releasing the hydrogen gas. So students, what kind of reaction is this? This is a single displacement reaction. Look at it, because how we are going to see this? Zinc is 2 plus. Hydrochloric, you can write H plus and Cl minus. Always when they are just combining, positive and negative. Zinc combine with chlorine. Then what happened? Zinc chloride are formed. Zinc chloride. Then H plus, they are just releasing H plus as a hydrogen gas. Can you guess how we are going to identify this hydrogen gas? It's like a colorless. How we are going to see this hydrogen gas? You can, when you are just take this hydrogen gas in a tube, test tube, in a boiling tube. So when you put alcohol into that gas, you can heard some sound. It's a pop sound. So you can identify the hydrogen gas. Now here is acid, second one. This is the second chemical property of acids. Acids react with carbonate or bicarbonate. Acids react with carbonate or bicarbonate to evolve carbon dioxide. This is sodium carbonate. Look at sodium carbonate plus HCl goes to sodium chloride plus water plus carbon dioxide. Sodium carbonate, you can write it Na plus carbonate CO3 2 minus. Hydrochloric, you can write H plus and Cl minus. Right? So look at Na plus, it's a positive ion. Cl minus is negative ions. The combination of sodium plus and Cl minus is that releasing the sodium chloride. And the other one is H plus and carbonate. Bicarbonate releasing just like water and carbon dioxide. So it's a milky color. Carbon dioxide is a milky color. So you can identify this carbon dioxide gas. So when you are writing the chemical equation, you should put the physical state. If you are not putting those physical status, that means you are in trouble. So you have to put it physical states and remember to balance the equation. Look at how many are there? Sodium is how many? Sodium is 2 and we are just adding 2 here. So if we are just adding 2 here, then what happened to the chlorine? Chlorine also 2. Then here is 1, so we are just putting 2 here. Now the chemical equation is balanced. Look at it, 2 hydrogen and 2 hydrogen, 2 chlorines, 2 chlorines, 2 sodium, 2 sodium, 1 carbon, 1 carbon. How many oxygen are here? 3 here. So 1 and 2 all together 3. These are the reactants, these are the products. Now we are just moving to the next one. Acid react with bases to form a salt and water. Acid react with bases to form a salt and water. The famous example is potassium hydroxide. If you like, you can write it sodium hydroxide also. When sodium hydroxide combine with the hydrochloric acid, so what are the products in here? NaCl, that means sodium chloride, that means salt plus water. This is potassium hydroxide combining with hydrochloric acid, and then the releasing potassium chloride and water. This is the basic chemical properties of acids. This is, you can see, this is sulfuric acids, nitric acids, and sometimes the nitric acid, sulfuric, these are the strong acids. Students, now we are going to see the uses of acids. So, first of all, what is the first one? Hydrochloric acid is a strong acids. These are the uses of hydrochloric acid. The first one is removing rust from steel object. Removing rust from steel object. You are just familiar with these uses. Refining common salt. When you already, I think you already know about the third lesson of grade 11. The grade 11 third lesson, that is a mixture. So, you are just familiar with this industry. We already discussed about that. Refining common salt. There are some tanks are there. So, only then those tanks we are using hydrochloric acid to refining common salt. Third one, making chlorine. Making chlorine, bleaching cloth and thread. Making chlorine for making chlorine for bleaching cloth and thread. Next one is digest food in the stomach. When the process of digestive system, so hydrochloric acid keep in stomach. Now, the fourth one, the fifth one is to make gelatin from bony materials in food industry. So, this is the main uses of hydrochloric acid. Now, we are going to see how making the gelatin. So, now students, you can see this video.
Everyone knows gelatin, that ingredient which makes our fruit gummies so chewy and melt in the mouth. Its use and tradition date back to ancient Egypt. Back then, gelatin-like mixtures were used as a natural glue. In the Middle Ages, gelatin was finally adopted as an ingredient for jelly-like food products. Nowadays, gelatin is part of our everyday lives. It's an indispensable natural ingredient not only in countless food products, giving them shape and texture, but also in pharmaceutical capsules for the protection of substances and their perfectly timed release into the body. Both powder and leaf gelatin are used worldwide for home cooking as well as by chefs and pastry cooks in restaurants. So how is this versatile product made? You can actually compare it with home cooking. Just allow the liquid released from skins or bones during cooking to cool down, and you get gelatin. Of course, to produce leaf or powder gelatin, there has to be a much more complex process of extraction, purification and drying. Let's have a look. Just like in your kitchen, using a safe ingredient is a prerequisite in industrial gelatin production. This is why all raw materials have to undergo rigorous testing. Only strictly controlled products from registered slaughterhouses are used. Quality is all important. All GME members produce accordingly to ISO and/or other high-level food safety and GMP standards. In the first step, the collagen-rich raw material is chopped up and placed in a solution in order to begin the extraction of gelatin. In the extraction stage, the solution is heated. After this, solids and fats are removed, leaving only the gelatin solution, which brings us to the purification process. The gelatin solution is passed through very fine filters, removing the last traces of fat and fine fibers. In the final step, Calcium, sodium, and other salts are removed from the gelatine. The clear solution is then concentrated in a vacuum evaporation system and thickened to form a honey-like mass by water evaporation. The highly concentrated gelatine is then sterilized under strict hygienic conditions. During the entire manufacturing process, no chemical modification takes place. Next, the honey-like mass is cooled and pressed through a perforated plate, which results in jelly noodles. These noodles are then dried and ground into grains, which are stored to await further processing for different customers and applications. As an all-round natural product, gelatine can be used in a variety of ways. The specific requirements of customers can be fulfilled on the basis of gel strength, viscosity, etc. It also causes no allergic reactions, is free of cholesterol and gluten, and since it is a natural food and not an additive, it complies with clean label standards. After all, gelatine is a real champion of the food industry.
Now we are going to discuss about another uses of acid. It is making aqua reagent. That means it's used to dissolve gold and platinum. So this industry, so we are going to see this video. Before that, your students, don't do this experiment in your home, right? It's really dangerous when you are doing this. Just look at how we are going to make the aqua reagent.
Greetings, fellow nerds. In this video, we're going to dissolve a gold coin in acid. Here is the coin. It's a 1/20th troy ounce Canadian maple. Now we add 10 milliliters of concentrated 12 molar hydrochloric acid. By itself, the acid does not react with gold, so we add another 1 milliliter of concentrated 15 molar nitric acid. The mixture is gently heated to speed up the reaction. Eventually, the mixture will turn yellow and bubble as the gold starts dissolving. We showed in a previous video that gold will not dissolve in either hydrochloric acid or nitric acid alone. What's happening here is that the nitric acid is first oxidizing the surface of the gold. Then the chloride ions in the hydrochloric acid reacts with the gold ions to form a complex ion that dissolves away into solution. The nitric acid then further oxidizes the surface and the process repeats. Other oxidants also work, but nitric acid is the easiest to work with. The bubbles you're seeing are nitrogen dioxide gas along with some nitrosyl chloride, chlorine, and nitrogen monoxide. This mixture of hydrochloric and nitric acid is also known by the name of aqua regia. Aqua regia does not destroy all metals though. I showed in a previous video that ruthenium is totally immune to aqua regia. Looks like the reaction is slowing down. I'm going to add another 1 milliliter of nitric acid. Overall, what we're producing in this reaction is chloroauric acid. There is a famous story among chemists. During World War II, Hungarian chemist George Dehevsey dissolved the gold Nobel Prizes of German physicists Max von Laue and James Franck in aqua regia to prevent the Nazis from finding them. This deep orange solution was what they would have seen on the shelf. All the gold atoms are still there as ions and can easily be returned to metal with the proper reducing agent. Looks like the reaction is complete. We have destroyed a gold coin and converted it to chloroauric acid using aqua regia. Leaving it for a few weeks in a desiccator bag, we can dry it and produce the solidified form of chloroauric acid.
Now you already know the uses of hydrochloric acid. Now we are just moving to the sulfuric. That means sulfuric is strong acids. It's a what? Highly corrosive. This is the first one. Production of fertilizers. Production of fertilizers such as ammonium sulfate, supersulfate, paints, plastics and detergents. Next one, next use, in making fiber and dyes in lead. Lead accumulators as the electrolyte. Third one, drying gases. Concentrated sulfuric is used as dehydrating agent. These are the three major uses of sulfuric acids. Now we are just moving to the acetic acid. Acetic acid is what is the chemical formula of acetic acid? CH3COOH. So, the first one is what? The famous use. In your home also you are just doing, not you, at least your mother. She is using vinegar to prepare some foods, no? First one is food preparation, we are using what? Acetic acid. This is acetic acid. It's a weak acids, because that means we are just consider about these weak acids, means this weak acid they can ionize but in weakly. That means they are just releasing hydrogen ions to an aqueous medium incompletely. So, these are the uses. Second one, making synthetic thread in textile industry. Third one is coagulation of rubber latex. 2016 O-level examination they already asked this question. So, remember, keep the main facts, main uses in your mind. Now, we are going to see the coagulations of rubber latex, how we are going to do this. acetic acid is paper industry and production of photographic films. Now we have the good knowledge about uses of acids. Strong acids just like hydrochloric acids and sulfuric acids. The other one is acetic acid. You already know that acetic acid is weak acid. So now we are going to see the chemical properties of bases. So here the first one reacts with acids hydrochloric to form salts and water. react with acids to form a salt and water. What are the acids? Hydrochloric acid, sulfuric acid and nitric acid. These are the strong acids. That means they can ionize completely in an aqueous medium. So, this is hydrochloric acid. The combination of hydrochloric acid and sodium hydroxide. So, what are the things that they are just releasing? Sodium chloride and water. Now, we are going to see how. Now, we can see how to write this equation. So, hydrochloric acid you can write H plus and Cl minus. Sodium hydroxide you can write Na plus OH minus. Students, I already told that H plus, that means positive ions always attract to the negative ions. Look at H plus is attracted to the OH minus, that means hydroxyl ions. That means H plus and hydroxyl ions, the combination of those two, water formed. So, next one, Na plus and Cl minus, what is it? The combination of Na plus and Cl minus is sodium chloride. This is sodium chloride. So, you can see this. This is the equation. Now, next one, look at the acid is completely neutralized. The acid is completely neutralized by the base, and this type of reaction is called neutralization reaction. So, I am just discussing neutralization reaction. The simple meaning of neutralization reaction is completely neutralized acid by the base. Acid means H plus ions are there and base hydroxyl ions are there. So, when they are just completely neutralized by base in acid, we call it this type of reaction, we call it neutralized reaction. Now, neutralization. What is the meaning of neutralization? Neutralization is the combination of hydrogen ions released by an acid with hydroxide ions released by the base to form water. To form water, they are just releasing H plus ions and OH minus ions. H plus ions in an aqueous acidic medium, OH minus ions releasing basic medium. So, this combination of H plus ions and OH minus, we consider it as a neutralization reaction. So, this is, we call it neutralization reaction. So, these are, look at, this is the potassium hydroxide, this is sodium hydroxide, these are what? These are the main strong base. So, students, do you know that sodium hydroxide is white soft petals that is stored in the plastic bottle? What is the reason for that? Because sodium reacts with glass, that is why always when the sodium hydroxide are in plastic bottles. Now, we are just moving to the uses of base. Here, the first one, the sodium hydroxide is a strong base. First one, refining petroleum product. This is the main use of sodium hydroxide. Now, we are going to see this refining petroleum products.
Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking. is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery.
Now we have the idea of the petroleum products. Now we are moving to the use in laboratory as a strong base. I told it's a main common fact of sodium hydroxide. Sodium hydroxide is a strong base. Third one, production of soap, paper, artificial, silk, paints. So those are the uses of sodium hydroxide. Now we are just moving to the magnesium hydroxide. So here students, you should familiar with the chemical formula. This is sodium hydroxide, you can write it NaOH, and this is magnesium hydroxide, MaOH twice. So first one is purification of molasses in sugar industry. This is, now we are going to see how to produce the molasses by using sugar industry. Here you can see this video now. Now the last use of bases is milk of magnesia. Milk of magnesia is used as an antacid to relieve gastritis. When you have gastritis, you can use milk of magnesia. Those are the uses of sodium hydroxide and magnesium hydroxide. Now we are just moving to the uses of salts. Now we have the basic knowledge of acids, bases, and their physical properties, chemical properties and uses also. Now we are just going to discuss about the uses of salts. Salt is a what? It's a neutral. What are the example of salts? Sodium chloride, that's a famous example of sodium chloride. And the copper sulfate, sodium sulfate, those are the example of salts. First one, sodium chloride, just like table salt. First one, flavoring food as a food preservative. We can use sodium chloride as a food preservative. Second one, to produce chlorine hydrochloric acid. To produce what? Chlorine and hydrochloric acid. Third one, to produce sodium hydroxide, glaze, earthenware. To make soap. When there is a sodium, what is the use of sodium? That means to make soap. When just like just imagine baby soap and the sunlight, what are the elements that they are just present in those soaps? Sodium and potassium. Which one is the best? Sunlight soap or baby soap? Definitely baby soap. What is the reason for that? Because the reactivity is less when we compare to the sodium. Sunlight and the other main soaps, they are just using the sodium. But in baby soap, they are just using the potassium. The best one is what? Baby soap. I think you should use that baby soap. It's better for your skin. Right? Next one, copper sulfate. So those are the uses of copper sulfate. The first one is used in electroplating. And the second one is in paint industry as a fungicide. And in agriculture, you can use the copper sulfate. So what is the color of copper sulfate? You already know that, right? Because you have the laboratory in your school. The copper sulfate is a blue color and it's a crystals. But when the anhydride copper sulfate, what is the color of anhydride copper sulfate? It's a white color. Remember, anhydrides means there is no any water. They are just releasing the water. So anhydride copper sulfate, the color of anhydride copper sulfate is white. The last one is used making chemical reagent, just like Benedict and failing solutions. You are just familiar with these two words when I thought you have the knowledge about those things. This is the first lesson of grade 10 science. So here, now we are moving to now we have knowledge about physical properties, chemical properties and uses of acids and bases and salts. Now we are going to discuss about the application of acid-base neutralization reactions. You already know the meaning of neutralization. Now we are going to use what are the applications. First one, milk of magnesia. Milk of magnesia used to what? When you have the gastritis, you can use the milk of magnesia. So milk of magnesia used to neutralize the acidity in the stomach. Acidity means hydrochloric acid in your stomach. So you can use what? Milk of magnesia. That means when you have gastritis, if you don't have gastritis, don't use the milk of magnesia because you don't have the gastritis now. Second one, quicklime is added to soil to reduce the acidity in the soil. So lime is, you are just thinking lime here, not the lime juice, not that one. This is a ash or something like that, right? That one, it's a basic medium, that line, quicklime, not lime juice. Remember that. Always students confuse this word, that's why I am just highlighting it. This lime is a basic, not acidic. Quicklime is added to soil to reduce the acidity in the soil. When the soil is acidity, we can use quicklime. The third one is baking soda. In your home also you are just using this baking soda. Baking soda and calcium carbonate. is used to bee stings. When you have bee stings, you can use what? Sodium bicarbonate and calcium carbonate. Right? And the last one, lime juice. See, this is the lime juice. You can use the lime juice or vinegar. That means acetic acid. Is used to wasp stings. If you have wasp stings, you can use the what? Lime juice or vinegar. These are the application of acids base neutralization reactions. Now students, I need to ask some questions about something, right? Just did you, that means your mother, when she preparing the dry fishes, did your mother add tomatoes in it? Tell to your mother, don't add tomatoes in dry fishes, because dry fishes that they have calcium element in dry fish. So when you just put the tomatoes in it, what is the chemicals in tomatoes? It's an oxalate. So the combination of calcium and the oxalate, it's the chemical compound is calcium oxalate. Calcium oxalate means stones in your stomach. Right? So don't put tomatoes in dry fish. Those are the, when you have the good knowledge of acids, bases and salts, then you already know that, because dry fish has calcium and oxalate ions in tomatoes. When the combination of calcium and oxalate, what happened? Calcium oxalate. That compound is formed. So now you have good knowledge about the acids, bases and salt. I hope you understood this lesson. First, you should know about the physical properties, chemical properties and use of those acids, bases and salts.